Hey guys, in this video we're going to learn how to plot choropleth maps using Python. So what is a choropleth map? A choropleth map is a special type of geographical map in which what you do is that you use color coding to indicate the quantitative values across various regions on the given geographical map. For example, let's say you have this particular map and you have multiple regions defined by their geographical boundaries. And let's say you have got a statistic, let's say population density. So you define a particular color scale in which according to the value of the population density, you take a particular color and then you color that particular region with it, right? So in this way a choropleth map gets created. So this type of map can be a very nice data visualization tool in the situations where you have the per region data, and that can be related to, let's say, population density or sex ratio or per capita income and so on. So any kind of data which you have per region can be a country at country level or at state level or district level, then you can easily draw it on any kind of geographical map using this particular technique. So what we're going to do in this particular video is we're going to learn how to draw choropleth maps using Python. Specifically, we'll be using plotly for doing that. So without any delay, let's get started. Okay, so let's get started by familiarizing ourselves with several terminologies here. So Plotly is actually a technical computing company that develops online data analytics and visualization tools, and they provide various scientific graphing libraries for, let's say, Python, R, MATLAB, Perl, Julia, Arduino, and even some REST APIs. So that is what Plotly does, and we are more specifically interested in plotly.py, which is an interactive open source and browser based graphing library for Python. So you can install it by simply doing pip install plotly. You can simply run this command in your terminal and it will install plotly.py for you. And we'll be using plotly.express, which is a new high level Python visualization library, which is actually a wrapper over the plotly.py, and it basically exposes a simple syntax for complex charts. So Plotly Express is also a part of Plotly only, so we'll be more interested in that. And other than that, there is something called GeoJSON, which is an open standard format which is designed for representing simple geographical features along with some non-special attributes. So for example, let's say in a map you need to draw a particular color inside a particular region, right? So in order to do that, you need to know the coordinates of that particular region so that you can do your drawing, right? So for that, you use the GeoJSON files which provide you that particular data. So a GeoJSON file contains a list of features. So each feature can have this particular format where you have the type, then you have got geometry where you can have multiple coordinates, and then properties can contain all your non-special attributes. So with there you can put, for example, name, so you can put anything else also there. So in this way a GeoJSON format is used for defining the GeoJSON files, which can be used for defining the complete geographical features for you. So that is GeoJSON. And finally there is something called Mapbox, which we'll be using a bit in the end, but it's not that important for now. Okay, so what actually we're gonna do in this particular video is that we're gonna take the example of this particular list of states and union territories of India by population. So here we've got a list. So you have got one column where you have got the name of each state in India, and then you have got all these columns which are several statistics that you have got, right? So let's say I'm interested in the population density that you have got here, and as well as the sex ratio. So these two things I would like to draw and in the form of a choropleth map, right? So that is what I'm going to do in this particular video, and hopefully we will learn a few concepts related to drawing the choropleth maps. So what are we going to do is the first thing that we need is the GeoJSON file for Indian states. That is the first thing that we need, right? So you can just go ahead and search for the GeoJSON file for Indian states, and you should get a lot of results. I got around 3 or 4 results which I checked, and I think this one was the best map that I could find because of the size that it had. It is around 7 to 8 MB, which is much better as compared to other GeoJSON files which are around 22 MB. So that's why I selected this one. So you can just click on download and then select this GeoJSON file format. So that is available. So now I will just be doing import JSON, and I will just import that particular JSON file. So India states is equal to json.load. So actually I've already downloaded it by the name of states underscore india.geojson in my desktop. So I'm just gonna read it. And now if I try to look into it, India states features 0. Let's take a look at the first feature in the list of features. So this is a particular feature which is representing, I think, a particular state. So let's see which state is it representing. So in the properties I can get a hint, and yes, it is representing Telangana. This is a state in India, so it is representing that particular state. So if I go for features 1, then it should be some other state that it should be representing, right? So it seems like it has a lot of coordinates, as you can see. So it is Andaman and Nicobar Island. So in this way we can get the information about these Indian states geographical coordinates that are there, right? So we've got this information, so this is fine. And the other thing that I need, other than the GeoJSON data, I need the main statistical data that I have, which I need to plot. So this data, which is in the form of an HTML table on this Wikipedia page, that can easily be downloaded by using the pandas library. And I've already made a video about how to easily download HTML tables using Python. So you can check that out. And I've already downloaded this particular table in a CSV file format. So I'm just gonna take it directly. I'm gonna do it like this. df is equal to, so let me just import pandas as PD. So df is equal to pd dot read CSV, and the name of the CSV file is India census.csv. So this name is what I've given to this particular file. So let us just check the head of this particular data frame that we have here. So look at that, the same data that we saw in that particular Wikipedia table. You have got the state or union territory names, and also in the last you have got the density and the sex ratio columns, right? So we've got this particular data as well. One thing that I can do here is to do some kind of pre-processing over my data of the density, because that is in this format 828 slash kilometer square, right? So that particular format can be fixed a bit to make it numeric. I would like to have it as some numerical data. So currently we have got density A. This is the name of my column, right? So I can do some kind of, I can apply some kind of transformations upon it. So apply lambda, so it will take, let's say, x. So what I want to do is I want to do x dot replace, or before that I will just split it by slash, and I will take the first element, which is these numbers, and then you can see these commas as well, right? So I can just replace these commas with empty spaces and then convert it into an integer. So that's it. This will make it a column with integer values, as you can see. So this is what I wanted to do. So let me just call it df density. So this will be called the density column. So yeah, so this is a bit of pre-processing that I'm doing here. Okay, so this is done. Now the other thing that we need to understand here is that we need to create some kind of mapping between the GeoJSON features that we have and the data frame that we are having. And for that, what plotly.express does is that it wants you to specify a particular key called ID in each feature of your GeoJSON file. So currently, if we try to look at India states features 0.keys, we will find that there is no ID key, but we need to define a particular key called ID in our GeoJSON file in each feature, and that ID key will be mapped with a particular column in our data frame for getting the value for each region. So that is what we need to do here. So I'm just gonna do I'm just gonna write a loop here for feature in India state features. So that is what I'm gonna take from here, and then in that feature I will just provide ID. Now what should be the ID, right? So that is what I need to understand here. So the ID can be something from the properties. So usually that is what we do. So in the properties you have got all these values. So if you just try to look at all other features, properties, you will find that state code is something which keeps changing, right? Also this particular value, but I think I can go with the state code. So that's why I'm just gonna do feature properties, and let us just take the state code. So this will be my feature ID. So that is what I'm going to take from here. And now in order to map this ID with the names of these states, I'm just going to create a dictionary which I'm going to call state ID map. So this will come handy when I'll be trying to map these IDs into a column in my data frame. So state ID map is something like this. And then in the state ID map, so only this name of states is what I can use for mapping with the GeoJSON features that I have right now, right? So that's why I need to use a dictionary which will have the name of the state and the corresponding ID. So this name, the name of this particular property is st underscore nm. So that is equal to feature ID. That's it. So this will make my state ID map. As you can see, state ID map looks something like this, which is fine, right? So now I'm gonna just define a new column. Let us call it ID. Again, you can call it anything. So df ID. Now I can just gonna map. So df ID is equal to df. So I'm now gonna apply a particular function over state or union territory column. So I will take each value of the state or union territory column, and then over that I will apply the dictionary, the state ID map, so that we can get the IDs. Dot apply lambda x. So what we do is state ID map x. That's it. So this should do it. So let us try to see the two newly made columns, which are density and ID, that we have here. So yes, so we now have got all the data that we need for mapping the data frame with the GeoJSON file. So now we are ready to draw our the coropleth map. So for that I'm just going to import plotly.express as px. So that is the one thing that we're going to do. Another thing is that the Jupyter notebook that I'm using right now, if I plot anything, that will be plotted on my Jupyter notebook only, but that will make my Jupyter notebook a bit too heavy. So in order to just draw the plot in some new tab in my browser, I can do something like this: import plotly.io as pio, let's say. So I can do pio.renderers dot default is equal to Firefox, for example. So that I can do. So now what will happen is that if I just try to see any particular figure, if I call fig.show on any particular figure, then that will be displayed in another tab. So in this way my Jupyter notebook will remain a bit more easy to check, because in that if I just try to draw anything on my Jupyter notebook itself, what will happen is that the size of my Jupyter notebook will get too much and it will be difficult to manage it, for now at least, while I am giving this tutorial. So that's why I've done that, and now I can simply do px.coropleth, and now I've got a lot of things to define here. So the first thing is data frame. So let us start with that. Df is my data frame. What else can I define? So anything else is a keyword. Everything is actually a keyword argument. So now after df I have to define everything as a keyword argument. So now the second most important thing here is the locations. So locations will be the name of the column whose values will be used for mapping with the feature IDs. So that is the ID column in my data frame. So that's why locations is equal to ID. Then I have something called GeoJSON. So GeoJSON is equal to the name of my GeoJSON object that I have. So GeoJSON is equal to India states. And now color. So color, here I have to define the name of the column which will be used for coloring. So let's say I'm gonna go with density for now. So density, that's it. And what else do we have here? Okay, so this much data seems good. So let us call it fig. So now I can do fig dot show. So let us just run it and try to see what happens. So here we go. We have got it rendered, and now you can see one important thing here is that India is out of focus here because this is being the scope of this particular map is the whole world. So that is one thing that we can notice here. So we can resolve that by doing, let's say, scope is equal to, let's say, Asia. So that we can do. So let's see what happens if we do that. Okay, so now if we look, we have got only Asia in the scope as we can see here. But again, the thing is that we have got a lot of these countries which are actually not required, right? So actually we can remove them as well. So let us see how to remove everything else while we are focusing on only that part which is available through our GeoJSON file. So for that we can do fig.update geos, in which fit bounds is equal to locations and the visible value is equal to false. So let us see. Okay, so here you go. We have got the focus only on India now, because now we are only showing the part or the features which are available through the GeoJSON file. That's why we are only getting the India map now, right? So yeah, so this looks fine, but now let's come to another important question, which is about the quality of the visualization that we have here, right? So we can see that most of the graph is actually blue, which is quite low value, and the highest value is only with this particular region, which is 11.297k, 11,000 something, but other areas are around 200, 300 and 400 or so. So now as we can see that what is happening here is the spread of data is actually not linear. It is a bit different. The spread is too much along the line, because there are a lot of values which are spread at long distances here. So if we just try to see df density, we can see that all these values, and then you have got this particular outlier, you can say, but it is not actually an outlier, because you have got something 9,200 something as well. You have also got some other big values here, right? And then you have got 17 as well, 52 as well. So we've got some range of values here which are varying a lot, and what we can do in these kind of cases is that we can take the logarithmic scale. We can convert these values to their logarithmic values. So let us see what happens if we convert these values to their logarithmic values. So let me first of all import numpy, and let us see. Because the problem with current spread of values is that it is not showing us good visualization results. That's why we are just going to tweak with the numbers. So it is np.log10. Let's take log base 10, and now as you can see, most of these values are in a particular range. They are in the range of 1 to 4, as you can see, right? So since we took the log of these values, now the magnitude is quite close to each other, and this should give us much better results. So let us call it a new column in our table, which is called density scale. Density scale is equal to this, and now the color is equal to density scale. So let us see what kind of figure do we get from this. So here you go, you have got this much better diagram, and now we can see some more color variations in our figure. So we can see these values, right? So now it is much better to see. So we are now getting an idea that these regions that are up here, they have quite high density. These are a few states, and now we can see some kind of a limitation, that is, which is I do not know which state I'm talking about while I am hovering over it. I know the ID and the density scale, but I do not know which state am I talking about, right? Although I know that this is Punjab, this is Haryana, and this is Uttar Pradesh, Bihar, and West Bengal, and so on. These are the state names, but still, let's say we want to put some name to these values, right? So that we can get some more information while we are hovering around. So for that, what we can do is we can provide that information. So let us see how to do that. First of all, let me put it like this. Okay, so scope is actually not required now. We can just remove it from here. Okay, so now there is something called hover name. So hover name will be the name of the column which will be used for the title of the hover box that you're gonna have. So hover name should be the name of the state or union territory. So I'm just gonna copy this column name here. So this is the name of the column which will be used for that. And let's say I also want to show the density of that particular state. Currently we can only see the density scale. So now to do that you will use hover list. So hover list will have, so I think that is called hover list. Let me just check. Actually it is hover data, but that has to be passed as a list. So it is hover data, and now I can provide the name of other columns which I need to be passed, which I need to show there. So I can just pass hover data density. That's it, and this should work. So here you go. Now we have got this, and look at that, Uttar Pradesh, and you've got the density as well. So this yellow part which shows the highest density, that is New Delhi, that is NCT, National Capital Territory of Delhi, and it is density of 11,000 something. So in this way now I can get some more information, like this is Kerala, Tamil Nadu, and so on. So yeah, so in this way we can have a much informative data visualization, as we can see. So yeah, so this was the density choropleth map for India. And now let me just give you a brief introduction to Choropleth Mapbox. So Mapbox is actually a company and also a kind of a platform, an open source mapping platform for custom designed maps. So they provide the maps and locations for various kind of development needs. So what Plotly has done is that they have created some functions which are wrapper over the map box. So what happens is that you have got px.choropleth mapbox function as well, which can also create choropleth functions, but it will use the base map which is provided by mapbox actually. So that base map will contain some extra information, will have more variants, and so on. So you can check out the mapbox layers which are available in Plotly from this particular link, and here you can see the different kind of map box base maps that you have. So let us check them out. Let me just search for it. So yeah, here you go. You have got these base maps in layout.mapbox.style. So you have got white background which will do nothing, which is the simplest one, and then you have got some free ones like these. Mapbox styles do not require a mapbox token, but a mapbox access token, but in these styles you will need a mapbox access token and might require some pricing plan, and so on. So let us see how to use the choropleth map box here. So most of the things which are here, these are gonna be same, and other than that I can provide some extra styling that I need. So what all I can do is I can provide a map box style. So the map box style I am gonna go with is cartopositron, let's say cartopositron, and I'm not gonna do this fit bounds thing for now, so that's why I will need to provide the center. So center will be a pair of latitude and longitude. So for India we can put it as 24 and 78, that should work. And also the default zoom value in this particular function is 8, I feel. Yeah, so it's 8, and we can keep it 3, that should give us better results. So yeah, so these all tweaks we are gonna do here, and then we are gonna be ready to show this particular figure. So fig equal to this, and fig dot show. So let's see. how it looks like. So look at this. What we've got here is, look at the base map. The base map is looking much more better. It contains some extra information. It is not the base map that you get in Matplotlib, and this has actually been downloaded from Mapbox by making some HTTP call. So if you are not having internet connection at the time of calling this particular function, then it might not work for you. So now what we can do here to make it look a bit more better is that we can set the opacity as 0.5. So this should give us a bit more better looking map. So here, as you can see, it is looking a bit more better, right? So yeah, so in this way we can have this kind of choropleth map using Mapbox base maps. So there are a lot of Mapbox styles which are available, so you can just try out each one of them. So yeah, so in this way we can do this. And now finally what we're going to do is, I'm just going to give you quickly, I'm going to give you an example in which we can learn a small concept before we end this video. So I'm just going to go with the sex ratio column in my data frame. So we have got df sex ratio. So now these values, what do they tell us is that for every 1,000 boys, this state has this much number of girls, right? So this is the sex ratio value that we have. So what I can do is that I can subtract 1,000 from it. So now I've got this particular data which is a bit more meaningful, which is telling me that it is this much girls are less, this much girls are less, or this much are surplus. So this is easily plotted. So this format of data can be easily plotted according to a color scale now. And now I'm just going to call it my sex ratio scale. So this is the sex ratio scale, and now let us try to draw it. Let me just copy it all, and what are we going to do here is replace color with sex ratio scale, and our data should show the sex ratio value instead of density. So that's it. So let us see how the figure looks like. So here, as you can see, we have got some information here and it is looking good. The data has been plotted, and as we can see that this is my scale, and according to it, Kerala has some positive value, that's why it is being shown as yellow. And then we have some other states. So in most of the North Indian states, the sex ratio is not that good, as we can see from here, as we can understand from here. So yeah, so this looks good, but we can make it a bit more better by using a diverging continuous scale. So let me show you what a diverging continuous scale is. So we have got the color scales in Plotly. So for example, this particular thing that you are seeing is a color scale, and they are of various types. So let us check out diverging color scales. So let me just search for it. Okay, so this example, as you can see, this is world average life expectancy. So they, in a diverging scale, you select a midpoint, and then above the midpoint you have a particular color scale which is showing a particular theme, a color theme, and then below that midpoint you have a particular color theme. So this helps you determine the difference between positive and negative kind of way, right? So for example, there is a midpoint, so anything above it should be considered as something good, and anything below it can be considered as something bad. So in this way we can get a more clear idea. It is a bit more intuitive in that way. So that same thing we can do here. So what I'm going to do is that I'm going to use a diverging color scale. So continuous color continuous scale is equal to px dot colors dot diverging dot let us go with brbg, and then color continuous midpoint equal to, let's say, 0. Okay, so now let us try to draw it. So now here you can see it is a bit more informative now. So now we are getting the idea that how worse is the situation in a particular area and how better is it in other areas. So we can see that in most of these North Indian states, as we can see, the situation is not that good because of the particular color theme, let's say the brown color theme that we have here, and then the almost white and the bluish color theme that we have for the positive values. So this gives us a better indication of what's happening. So yeah, so this is how you can use a diverging color scale. So in this way we have plotted another choropleth map for the sex ratio for the Indian states, and it looks fine, right? So yeah, so in this way you can make choropleth maps. You can make any kind of choropleth map depending upon the data that you have and the GeoJSON that you are using. So as an exercise, you can use the you can make a choropleth map which is about the number of COVID-19 cases which are in each Indian state or any state or of any country that you're living in. So that as an exercise you can do. So yeah, so I hope you enjoyed the process of going through this choropleth map plotting, and if you have any doubts you can put them in the comment section below. That's it from this video. Thanks for watching.